Hello, I'm Shyam, and in this video, I would be explaining the agentic AI-based travel planning assistant using LangChain. And the problematic is, travel planning is complex and fragmented, requiring users to manually balance multiple constraints, which traditionally the systems and chatbots cannot handle effectively. So the business goal is to automate end-to-end travel planning with scalable, explainable agent AI that reduces operational costs and improves user experience. Olama is used as it enables fast and private local LLM interfacing, supporting reliable multi-step agent reasoning without external API dependencies, and it's free of cost. The LangChain provides the agent tool orchestration and multiple step reasoning framework, while Olama serves as a local LLM runtime that executes the model that uses the LangChain agent. Here, the entire project folder structure is shown with the various folders and files, and they are all required to run the agentic AI. The data folder contains all the JSON, that is the JavaScript object notation files for flight, hotels, and places. And this should be used in the execution of the project. The output folder, which contains the trip details generated as JSON and TXT file along with the test results. And the src folder, which contains all the important py files, that is the python scripts, and test folder containing all the test scripts, readme, which contains the markdown file containing the entire description of the project, requirements.txt containing all the versions of the library to be installed, and export project to pdf .py file that contains the script to take the entire folder content to a single pdf file. Most importantly, a virtual environment has to be created, that is a VENV, that contains all the proper versions of all the libraries required to be installed in the environment so that there are no application crash while running the app. And the Python version, that is the independent from the system Python, and side packages, that is Streamlit, LangChain, ReportLab, PyLab, etc., has to be installed in this, that is separate. And executable wrappers, that is Python, pip, Streamlit, PyTest, etc., that should be wrapped inside the VNP to ensure that all the executions use the isolated environment, and this environment can be activated using the scripts/activate.ps1 command. And here the export project to PDF file is explained, and which automatically scans the project repository, detects the true project root, and ensures that only relevant sources, that is .py, .json, .md, .txt files, are included for the PDF generation, which uses the report lab, that is the platypus API, and a single structured PDF is generated with proper breaks, headings, and all the proper structure that are required for the PDF to be generated. And the execution logs confirms the success route direction, file enumeration, and PDF generation, validating the correctness, thus generating the PDF. This is the starting of the PDF file, explaining where it is present and the main contents of the PDF and the number of folders. This is the JSON, that is flights.json JavaScript object notation file, which acts as a static knowledge base for the flight search tool. Each record provides price, departure, arrival, enabling duration cost computation. Data structure supports sorting, filtering, and ranking logic. So this is also used directly by the flight search tool in the tools.py file. This is the hotels.json used by the hotel underscore search method, and this file defines the hotel attributes for star, price, amenities based filtering, enables preference aware sorting, that is the budget versus luxury, etc., accommodation selection in the itinerary hotels with all the price ranges, supports fallback logic when strict filters fail, ensuring that the hotel ranking remains deterministic, city-wise, hotel-wise entries emphasizing leisure centric amenities, and ensures that the dataset driven recommendation consistencies, ensures hotel budget feeds correctly into the cost estimation, prevents mismatch city hotel selections, and city-wise hotel updates are also updated here, and ensures the PyTest schema coverage is done along with the cultural destination synchronization. This is the places.json file, which contains the powering attraction underscore search function, and each POI, that is the point of interest, has type plus rating for preference mapping, enables itinerary diversity logic, supports POI ranking and filtering, supports cultural itineraries, attraction day wise, and avoids repetitions. City with type mapping is also done with this file, and it's also used to test preference to type mapping, logic, and attraction with the type with the rating, and it's also used in the day-wise itinerary, that is the morning, afternoon, evening, etc. This is the README overview, which defines the business content and it sets the architectural expectations and explains every aspect of the application, its usage and its execution and the expected output. This is the SRC folder, contains all the important Python scripts, the first being the agent.py. This is the central orchestration logic. This defines the deterministic planning pipeline, contains the comment where the GitHub link where the project repository is placed. It also implements the deterministic agent travel planning pipeline that orchestrates modular tools, that is, the flight, hotel, attractions, weather, budget, etc., to produce a clean, structured JSON output aligned to the user's input and UI needs. It includes robust canonicalization logic to fix all the issues related to flights, dates, and the time mismatches, repeated attractions, empty itinerary slots, and inconsistent hotel budget data, and ensuring the stable and predictable output without React style prompting. And the system integrates Open Meteo for weather and Ollama for local LLM via LangChain to convert a structured JSON into an explainable human readable markdown itinerary while preserving the privacy and avoiding paid APIs. And overall, this file is the central orchestration layer that guarantees data consistency and reproducibility. And this also gives us the proper output from the raw inputs. This is the app.py, which is built for the Streamlit UI. There is a user interface that collects the trip details from the input and validates the inputs and the dates and the calls for the plan underscore trip method to run the deterministic tool driven pipeline, and it provides the JSON flights and it clubs the JSON, that is for hotels, places, and flights, along with the OpenMeteo weather app, along with the Olama summary, and it converts the raw structured outputs into the user-friendly section using formatter functions like for the trip, flight with canonical date times, hotel attractions, budgets, itinerary, weather, and it avoids the blank and incorrect UI fields. It adds the output persistence plus reproducibility by saving every run into outputs folder as a full JSON human readable TXT file for safe output. And it also ensures that this results are stored in st.session underscore state, so the outputs don't disappear on reruns. It provides full transparency and exportability by showing structured highlights, raw JSON, and enabling one-click downloadable buttons for JSON and text summary directly from the memory result. And there are no extra files required. This module centralizes data access by dynamically loading all the JSON files from the project data directory, removing hard-coded dataset parts from the rest of the application. It uses at IRU underscore cache of max size is equal to 1 to ensure JSONs are read only once per process and improving the performance and avoiding repeated disk input output during the tool or agent execution. And each dataset is exposed as a dictionary keyed by file name. That is, flights.json is given as data of flights, enabling clean, scalable access across all the tools. The design is fail safe and production friendly, and graceful handling of the missing folders or malinformed files without crashing the app ensures robustness during the deployment. Everything is done in this particular file. And this is the planner.py. In this module, it provides the date and itinerary utilities, generating a continuous list of trips, dates, and distributing points of interest evenly across those days. The date range converts ISO start end dates into a deterministic inclusive date sequence, ensuring consistent day-wise planning. The built day-wise plan method allocates POI per day and enriches each day with the weather data, that is the temperature, precipitation, etc., aligned with the date from the weather API response. The logic handles the edge cases gracefully. Uneven POI counts and missing weather data and leftover attractions on the last day to produce a stable and structured day-wise plan suitable for the UI rendering or the JSON input, and the output is done here. And in this schemas.py, this file defines the pydantic data schemas that strictly validates and standardizes across all the entities such as flights, hotels, attraction, requests, and itinerary outputs. This is also used to travel planning pipeline. It enforces file type safety, defaults, and constraints. That is the literal preferences, optional budgets, default POI types, preventing mal-informed inputs from propagating into the agentic logic. In the script, the field aliasing, that is from city, resolves Python keyword conflicts while maintaining compatibility with existing JSON datasets. By modeling both input contracts, that is the trip request, and the output structures, that is the itinerary and day plan, it guarantees predictable and production ready data exchange between tools, agents, and the UI. Here, the tools.py file defines all the LangChain tools functions and the power agents reasoning, covering flight search, hotel filtering, attraction selection, weather retrieval, and budget estimation, each returning clean structured JSON. It applies normalization, safe parsing, and deterministic ranking logic, that is fastest versus budget flights, star versus priced based hotels, preference awareness, and sanity, ensuring proper results. This file integrates external live data via OpenMeteo API, that is a geocoding plus forecast, without API keys, enriching static JSON dataset with real-world weather context. The budget tool also enforces the selection consistency by calculating costs strictly from the agent's top ranked flight search and hotel by adding the preference based local expenses heuristics to produce a UI safe, production ready cost breakdown. Now, the test folder consists of all the test scripts that are needed, and firstly, just for a sample, taking conftest.py file. This sets up the stable PyTest environment by dynamically directing the project root and adding it to the sys.path and forcing the working directory to the root so the SRC imports the relative path work reliably, and it defines the session scoped fixtures for the project root and the data directory, cleanly skipping the dependent tests if required. Resources are also checked, and if there are missing instead of failing the test suite. And in this file, it ensures reproducible environment dependent testing is done and prevents common CI and local errors like module not found and broken relative file paths, etc. All the test scripts are actually done after installing the PyTest libraries, and it's actually imported in the same Visual Studio Code terminal window, and we need to run the pytest-v to ensure that the all the test scripts are run and the outputs is placed in the respective folder automatically. And to execute the app, initially we need to navigate to the proper folder location, activate the venv using the streamlit dot activate dot ps1, and then we have to run the application using the streamlit run src slash app dot py command to run the app. This automatically opens the browser, else we need to click on the URL as present in the terminal window. In this app, on the left hand side, the user can give all the inputs required, that is the start, end date, the number of travelers, minimum star rating, budget, etc. And the corresponding changes can be seen on the input section on the right hand side. And the user can click on the plan trip button, which will produce the result for the chosen inputs. And the outputs will be where and the output will be under the planner output section where all the flight details, hotel attractions, and itinerary details can be observed as shown here. The selected flights along with the attraction details and the budget breakdown can be observed. Here the weather for the 6 days from the weather API is shown here. Here the raw JSON content can be seen, and this is expandable and can be collapsed as well. Here, clicking on the download JSON button will download the output file under the user's download folder. And similarly, the text file also can be downloaded using the text button. This is the folder where the two files are downloaded. The user can use the same session and choose different inputs. And here, luxury is chosen for Chennai to Bangalore, along with the max pricing is also given here. And on clicking on the plan trip button, the trip summary with the flight, hotels, and the budget details can be observed. And for the modified inputs, the hotel selected is now available and it's included in the budget calculation, as we can see. The budget breakdown for the luxury preference can be seen here. The downloadable exe text file containing the entire input-output itinerary and activities details as a summary. The same file can be present under the output folder as well after the execution of the plan trip button via the Agentic AI app. Thus, this project successfully demonstrates how agentic AI, powered by large language models, that is the LLM, and tool based reasoning, can transform traditional travel planning into an intelligent, automated, and user centric experience covering all the requirements. And thus, by integrating the structured data sets, that is the flight, hotel, attractions, etc., the real time weather insights, and preference driven logic, system replicates the decision making of the capability of a professional travel consultant. And here, this agentic architecture outperforms the prompt based chatbots by orchestrating deterministic tools with reasoning loops, enabling accurate personalization and constraint handling and real time decision optimization while significantly reducing manual operation and support costs. Built with modular system scales to external booking APIs, additional services, multiple LLM backends, demonstrating work level AI automation with clear enterprise and portfolio value is done. The system delivers reliable automation, business efficiency, long term competitive advantage, making it well suited for real world adoption by travel platforms and AI driven enterprises to deliver accurate and personalized itineraries at scale, reducing operational costs while improving the customer experience and the conversion rates. And here are the list of key insights and the takeaways shown. Thank you very much.